Hi my friends, today I have a two beautiful geometry problem for you. Given a circle in which there are 2 million randomly placed points, you are asked to find a line that divides the set of points in half as follows: 1 million on one side of the line and another million on the other side. The problem can be illustrated with Inventor, but cannot be solved. Yes? Let's create the illustration of the problem. We start a new part. We create the circle, but I want it to be red. Circle 2000. We have to apply an actual value for the diameter of the circle. Now I go back to the default color, finish sketch, make the dimension not visible, and create another sketch in the same plane. Now I have a Visual Basic application for you to create that 2 million points. However, we cannot create 2 million points, of course, because it would take us too long. Let's create only 10,000. Yes, I have here a stopwatch and we'll see how long it takes. I activate my program. I'll show you the solution. Alt F11 and I start the program. F5. I am asked to place a number 10,000. I start placing points and I start the stopwatch. You see what happens. They are like drops of rain, randomly placed but only inside the circle. No point is placed on the edge of the circle, only inside. The continuation is with the solution. Now you see 1 minute and 17 seconds to create only 10,000. Think of 2 millions. Now I ask you how to place a line, where to be their ends, to separate that 2 million points. If you ask for yourself how random is this placement of points, I can answer you very easy. Look, what is the distance here? This is the distance. More precisely, we can select precise value. This is the precise value for this point. What is the distance between 2 points? From this one to this one, aligned. Yes, no one points, I think, is placed on the line, because all of them are randomly placed. Even my line is placed randomly. Yes? So, what is the solution? I wait for you to think for yourself, and then I'll show you the solution. The solution is very interesting. As I promised, firstly, I want to start by showing the program for creating random points in a circle. To do this, you'll find the text of the program by using the link in the last paragraph of my description of this tutorial. Then you must respect the procedure. Firstly, Alt F11 to obtain this environment for programming in Visual Basic. Then go to File, New Project. This is the new project, user project number 3. You see there is a module here. Double click, and here you will paste in my mentioned text file. I do this now. Copy from the file, paste in the module. Now you see the program. The program, what you saw, is stop here. Yes, I can explain the program, but you are not prepared for this. So this is the point where we finished the generating of the points. Now I erase all in this sketch. There is a time only for erasing 10,000 points, and now I start the program. To start the program, you can use this icon or F5. You see, F5 if you are here, not here. Click on the module, F5, number of points 10 is by default. Okay. Do you want to continue? Yes, I want. And you see what is the continuation. Every 2 points are connected with a line. The total number of lines is 45. Be careful with the number of points, because this value 45 is very rapidly growing. In fact, this is the binomial coefficient or combination of 10 points taken as 2 at once. You can calculate this value by using this site ohrt.com, and if you place here the number of points and here how many for each line, 2, 10 and 2, the result is 45, as you already saw. If you place here 1000, the result is about 500,000. If you place here 10,000, the result is 49,995,000, and if you place here 2 million points, you cannot understand this number, because it is 1,999 billions, and the rest of millions. So don't try to place many points here. Important is the fact that the number of lines is finite, not infinite. Now we don't need to see the program. We don't use it at all. We have 45 lines connecting all the 10 points. We go with the solution. Now you have to be very careful. I draw another circle, very large, like this, and I continue with extending each line to that circle, as you can see here. Yes, in both directions. This is one. This circle is not projected here, so this is why extension is not stopping to the red circle. We continue with extending to the large circle with each line. As you can see. The result is a number of lines in the space. I want to make something significant. To continue this extension. Then I can eliminate. We suppose that we made all the extensions. Let me make another one, this one. So you can imagine that all the space is full of lines, but because they are finite, always will find a space empty without lines, like this polygon. Yes, here you can create a point. We suppose that we draw all the lines. Yes, we can place a point in such a space, such an empty space, and we fix this point in space. As you can see, we draw a line from that interesting point to somewhere outside this circle. Now I project the circle. Now the circle is projected in my drawing, and you can see this by hiding the sketch, and you see the projection now. Yes, good. Now I can rotate this line to the circle. Yes, the first moment is when it is tangent to the circle. Let's make it tangent. Yes, now the line is tangent. This is the first moment. Then I eliminate this tangency, this constraint, delete, and I continue to rotate the circle, the line through the circle to the very first point. I am sure that I'll meet one single point. Yes, never I'll meet 2 points. Why? Because I covered the space with the lines connecting points, and this point is outside of any lines in the space. Yes, this is the first moment. I make coincident this line with this point. Excuse me, Control Z. Now I eliminate all the lines, all extensions of lines, but I can eliminate very well all the lines. We have points, we don't have lines. Yes, the problem is with the 10 points. Yes, no lines. Okay, this one also delete. We rotate the line to the first point. Coincident this line with this point, but the point is not fixed. Control Z. Now I make all the points fixed. I move back this line here, and all of them are fixed point. Yes, so I make coincident the line with the first point inside the circle. I am sure that only one point is now intersected. Yes, I eliminate the connection with this point, which is this constraint, and I make connection with the next point, which is the next, this one, not this one. Important is that we always meet one and only one point. Now I apply Control Z. I place the line here, Control Z, and everybody can understand that I go through each point, being very sure that always I meet only one point, no matter how many points are. This is the way to number 1,000,000 points. 1, 2, 3, 4, 5, and now I am with this line separating 5 points above the line and 5 points below the line. This is the line I can color it to be sure that you will remember. In magenta, this line divides the set of points, 10 points here, in two sets of points, 5 above and 5 below. You can imagine 2 million points and a line numbering each one starting from the tangency to the inside till we number 1 million. When we go over 1 million, this is the moment. When we go over this, but not contacting this, we are sure that the line is between the two. Now we have 6 points above and 4 below. This is the solution, my friends, for this very nice problem, in my opinion, of 2D geometry. Thanks for watching. Bye bye.